Okay, so as part of our warm-up, we're going to talk about some new vocab and some old vocab. So the first thing we're going to look at is additive inverses. If you recall, an additive inverse is the opposite of the number. So additive inverse is what you add to something to get to 0. So the additive inverse of 4 is -4. The additive inverse of -x is x. The additive inverse of 5x is -5x. And the additive inverse of 8y is -8y. So again, the additive inverse is a fancy way of saying the opposite. Is a fancy way of saying the opposite. So what we're going to do today is something called the substitution method. In order to get a grasp on the substitution method, we're going to take the ideas and concepts from the first page in our review, which was on substituting in. So we took a number and we replaced the variable to get a numerical solution. Now we're going to take a variable and replace that variable with an expression. So everywhere I have an x, I'm going to replace it with 2y minus 1. So we're going to replace this x with 2y minus 1. So again, where there was an x, we replaced it with 2y minus 1. And now we're going to simply solve like we did in our homework. So we're going to combine like terms. 2y plus 2y is 4y. Add 1 to both sides. Divide by 4. And we get y is equal to 1. Your test will specify for 2 problems you have to use substitution, 2 problems you have to use elimination, and then the remaining problems you can choose which one works better for you or which one works better for that particular problem. So, because we'll talk about like when and why to use elimination versus substitution. Okay, and then in example 6, once again, replace your x with your 2y minus 1. So we have y minus 2. And then where I add an x, I'm going to replace it with 2y minus 1 equals 8. And now we're simply going to solve for y. So distribute the -2. Combine like terms. Divide by -3. And you get y equals -2. Same idea in number 7. We have 2y plus 3. We're replacing that x with 2y minus 1. equal to -5. And then we're going to distribute. Combine like terms. Solve for y. So what was really nice in this warm-up and in example 5, 6, and 7 is that they already told you what to substitute where and for what variable. They said, okay, you're going to take x and replace it with 2y minus 1. In the new stuff, we are not going to tell you what to replace with what. That's up to you to determine, okay, what variable should I solve for? Why would I solve for that variable versus this variable? And where do I plug it in? So we're taking that idea of a systems of equations from chapter 3 before break, and now we're applying it algebraically. So before break, we applied it graphically. So what you would have done is graph these two lines and find where they intersected. All right, Siri. Wasn't my phone, it's over there. So what we're going to do is solve for x. Hey, wait, I learned something. If you look at example 1, we have one equation that has coefficients 2 and 4, and we have another equation that has coefficients 1 and 3. If you are picking a variable to solve for, and one of the variables you pick has a potential to have a coefficient of 1, that is the variable you want to solve for. So like in the case of this problem, I want to solve for x in the top equation because it will not create any fractions. So I'm going to rearrange the terms in that equation so that it's x equals 12 minus 3y. So I'm going to solve for x so that I can take this equation and replace x in the other equation. So I'm going to substitute. It's like when I'm in the classroom, and then Mrs. Ward comes in, and then I come back to the classroom. You substitute your teacher like you're going to substitute the algebra. So we get -2, replace x with 12 minus 3y, plus 4y equals 9. You never want to substitute the equation you solve for into the equation you solve for it from. It's like you cannot plug 12 minus 3y into this x because it will just cancel out. Now you're just going to do algebra, so -24 plus 6y plus 4y equals 9. Combine like terms on the same side. Combine like terms on opposite sides. And we get y equals 3.3. Yes.
So basically, you're like rearranging one of the equations, and then that equation is the substitute?
Correct. And then once you get one of your variables' numerical answer, so in this case, y equals 3.3 is my numerical answer, I'm going to take that 3.3, plug it back in, and solve for x. So now you have 12 minus 9.9, which is 2.1. So what that means is if I were to have graphed these two lines, they would have intersected at 2.1, 3.3. In the case of example 2, I'm going to solve for one of the variables in the bottom equation because they both have coefficients of 1. So x equals negative 12 minus y. Since I solved for x, I'm going to replace x in the top equation. So it's 2 negative 12 minus y minus 3y equals 6. Negative 24 minus 2y minus 3y equals 6. Add 24 to both sides. Combine like terms. So negative 5y equals 30. Or y equals negative 6. Once again, you have to solve for x. So it's negative 12 minus a minus 6, or x equals negative 6, because minus a minus turns to a positive. So what that means is the solution is x equals negative 6, y equals negative 6. These would be intersecting lines. In number 3, you would want to solve this equation for y. So I get y equals 3x. So I replace the y this time with the 3x. So you get 4x plus 3 times 3x equals 26. 4x plus 9x equals 26. 13x equals 26. X equals 2. And last but not least, plugging 2 in for x so that you get y equals 6. We can apply these to word problems. So it says a soda and pizza cost $10.25. A soda and 4 pieces of pizza cost $18.75. What is the cost of a soda and a piece of pizza? So we can say that S represents soda, P represents pizza. So 1 soda plus 2 slices of pizza is $10.25. 1 soda and 4 slices of pizza is $18.75. And again, we want to solve for the variable that's easier to simplify. So in this case, you could solve for soda in either equation because they both have coefficients of 1. So we could say that 1 soda equals $10.25 minus 2 slices of pizza. And then you're going to replace that 1 soda in this equation with 1025 minus 2p. Combining like terms. And simplifying the numerical aspect. I get 2 pieces of pizza equals $8.50. So a single slice of pizza is $4.25. Using that idea, I can solve for 1 soda. And see that a soda cost $1.25. We can also use these ideas to determine when we should do or purchase something from one store versus another. So it says you can buy a CD at a local store for $15.49.
So I think that last one was right.
Why?
Because you said that the slice of each pizza was $4.25.
Correct.
And then soda was $1.75.
Correct.
But then $4.25 times 2 is $9.50.
$8.50. You good? Do you all believe me? Oh, I didn't hear you say never mind, sorry. Alright, so if one store is $15.49 for a CD at X numbers of CDs, and the other store is $13.99 for X CDs but costs $6 to ship, what store would you want to choose when, and when are the stores the same? So we want to know when the number of CDs you buy costs the same whether you go in-store or online. So if Y represents the cost of the CDs and X represents the number of CDs, we're going to set the two costs equal to each other. Because you're basically substituting one Y in for the other. So I took that 13.99x and replaced this Y here. Solving for X, we get 15.49 minus 13.99, which is $1.50. Dividing 6 by 1.5 gives X equal 4. So if you're buying 4 CDs, the cost is the same in-store and online. If you're buying 4 CDs, the cost will be the same both in-store and online. Your homework is the front and back of the next page.